Hello again. It's now time for lesson 7.2, adding and subtracting polynomials. This is going to be very, very similar to when we were combining like terms, except it looks a little bit different because I have all these parentheses in here. So when I say adding and subtracting polynomials, this amount right here, this is a polynomial. It's called a trinomial. And to that I'm adding another trinomial. So those parentheses are just showing you that this is the first polynomial and this is the second, and we're going to add those, and in the second section here we're going to subtract them. Sometimes the parentheses make a difference, sometimes they don't, and that's what I'm here to show you. So there's two ways that you can do this. I do have one that I prefer, but I thought I'll show you both because it wouldn't be very nice just to show you my way only. But basically, you can add them vertically or horizontally. All you're going to be doing is combining like terms. And remember, like terms are like totally stuck up. They will only hang out with other letters that look just like them. So x and x squared will not hang out because x squared has a little 2 and the other x doesn't. So they cannot be friends. It's terrible. I know. Okay, enough of that. We can use keep, change, change before we start so that you're less likely to make mistakes with subtraction. I've been doing this a long time and I see a lot of teeny tiny little mistakes happen when you don't keep, change, change. I don't require you to do that. I'm going to do it on the notes because I've seen through the years the common errors that happen, and I feel like that's the best thing for you. So if you got it, you don't need to, you know, hey, that's negative 8x, it's not minus 8x, then fine. But I'm going to keep, change, change on this. All right, so let me show you the two methods. I want to add these two polynomials together, and the first thing I'm going to do is look for any subtraction and add the opposite. So I saw a little spot right there. Let's zoom in a little bit closer here. Okay, vertical method means I'm going to be setting these up one on top of the other, and all we do is we line up the like terms vertically. It's kind of like we have to line up the decimal point. So I'm going to write this first polynomial. It's negative x squared plus 5x plus 4. And to that I want to add 3x squared plus negative 8x plus 9. So this is what I mean by lining up the terms. Negative 3x squared goes with the other x squared. And then this negative 8x is going to combine with that x. And then the 9 would go with the 4. Neither of them have a term. And we're going to add those together. So negative x squared plus 3x squared, remember that means it's really negative 1x squared. That makes this 2x squared. Remember, we're just adding the coefficients. We do not add any of the exponents up. We add exponents when we're multiplying bases, right? Right now we leave it alone. We're saying we have negative 1x squareds and 3x squareds. How many x squareds do we have? Don't change its name. All right, I have 5x and negative 8x. 5 plus negative 8 is negative 3, and I still have an x. Don't we all? 4 plus 9. That's 13. And when I look at this expression, I see there are no like terms. We're good to go. So that's the vertical way, rewriting it like that. There's also a horizontal method, and hint, hint, this is the one I actually prefer because I don't like to rewrite things if I don't have to. You know? It's crazy. That's just how I am. Okay. I'm going to keep, change, change this. And did you notice anything about these problems? They're the same problem. I know. I didn't mess that up. I know that they are the same problem. I just wanted you to make sure, I wanted to make sure that you understood that you can get the same answer either way, that either way works. That's kind of the goal here. Let's see if I can get this to focus a little bit better. I think that's better. Let me look. Yes, all right. So I'm going to keep, change, change it. Now I want you to notice something. There are parentheses in here, and I know that you've been trained that whatever's inside parentheses, that has to happen first, right? But can I add any of those together? No, none of them are like terms, so I can't. This is really all addition here. Do you see that? There's addition signs between all of these terms. Does the order that you add numbers matter? No, it doesn't matter. And there's nothing next to these parentheses either. That means I don't need to distribute anything before I begin. So the order that I add these really doesn't matter because it's all addition and there's nothing that needs to be distributed. So I'm just going to identify the like terms and combine them. So negative x squared plus 3x squared, well, negative 1 plus 3 is 2, so I know I have 2x squared. And then I'm going to look and I see, okay, I have 5x, negative 8x, those two go together. 5 plus negative 8 is negative 3, so there's my negative 3x. And last but not least, this 4 and this 9, neither of them have a variable, so I can add those together, and that equals 13. So with this one, you're just looking for the like terms and combining them. I hope you like that method too. We'll see. You can do it either way. I'm not going to be upset if you don't like my way better. It's all right. So let's try this. The very first thing I think you should do is keep, change, any subtraction, so you're less likely to make those little errors. So I'm going to keep, change that. And it's all addition. There aren't any numbers next to any parentheses. I think I'm just going to do it my way. If you want to do it the other way, if you want to go ahead and line them up vertically, you may. But I think you're used to just doing what we're doing right now. So there's 3a squared. I see an a, but it doesn't have a squared on it, so those guys won't hang out. Remember, this guy with the 2 is like, nope, you're not cool enough, you don't have a 2. I'm going to hang out by myself instead. All right, next. Okay, you know how you just learned that we need to write things in standard form, and that means we go in order by degree? When you see the constants, when you see numbers without letters, letters will always go first. So the degree of 5a, that's a degree of 1. 8 and negative 1 have a degree of 0, so I want this a to be next. There are no other a's that go with it, so I'm going to write plus 5a. And then I have 8, I have negative 1. When you take 8 plus negative 1, it is 7. Ba-bam. Done. All right, move over. We've got another one. Oh, this time I have a trinomial and a binomial. It's okay. We're going to keep, change all these subtractions so that we're less likely to make errors. And again, it's all addition. There's nothing that needs to be distributed. I can add these in any order that I want. So I'm going to go ahead and start combining some like terms here. I see the highest degree I have is 2. Actually, it's a master's. Hee. All right. Anyway, sorry. I want my doctorate, so you can call me Dr. Trombley instead. Maybe someday. Maybe someday my dream will come true. All right. 1x squared, 7x squared. That means I have 8x squareds. Plus, now I see there's a number here or a letter. Remember, letters get to go first. The degree of this negative x is 1, and the degree of this negative 2 is 0. So there's a negative x and another negative x. Those don't cancel each other out. You end up with negative 2x. Because remember, this means negative 1x and another negative 1, and a negative 1 plus a negative 1 is a negative 2. And all that's left is this little negative 2. And now you're done. If you wanted to write it like this, that would be even better. Normally, when you're writing an expression in simplest form, we don't have this whole plus negative business going on. That's a strategy that we used so that we're less likely to make errors. This is actually the best way to write it. Writing it like this is kind of like your first step. So I would accept either way. Down the road, you will probably end up having to eliminate this plus negative. But right now, it's okay. It's all good. Okay, so you're thinking maybe, wow, that's pretty easy, right? It gets a little bit harder with subtraction, right? I always start off with the easy stuff and then ease you in. But when you subtract polynomials, you have to remember that a subtraction sign in front of parentheses has to be applied to everything inside. You're going to be less likely to make errors if you rewrite this. I promise you. So we're going to want to rewrite this as an addition problem and make sure, of course, that all of your answers are in standard form. So I want to use the vertical method, but before I do, I'm going to keep, change this whole thing. This little keep, change is an easy one. But do you see how I have a subtraction sign in front of those parentheses? This means that here's my first polynomial. I want to subtract all of these things, right? I know you're used to adding the opposite, but this means adding the opposite of everything inside there. So this is where I think you should rewrite it. This first stays the same, it's fine. But this second problem here, this means take the opposite of everything in there. What's the opposite of a positive 2y squared? It's a negative 2y squared. What's the opposite of a negative 5y? A positive 5y. And what's the opposite of a positive 3? A negative 3. So when you are subtracting polynomials, you have to keep, change everything inside the parentheses that follows the subtraction sign. Because it means add the opposite of all that stuff. Now we're going to go ahead and set it up vertically, just to humor you, you know, because I'm guessing you just like my way too. That's okay. All right. Here we go. And then we look at our next one. I have negative 2y squared. I'm going to put that with the y squareds. And I have a 5y. That's going to go under the y. And I have a negative 3. And remember, we're adding those together because we changed it to addition. When you have 1y squared plus negative 2y squared, you end up with negative 1y squared, which I would just call a negative y squared. 4y plus 5y, that's 9y. And 2 plus negative 3, that is a negative 1. So right here, this is already written in standard form. We're good to go because it goes by the highest degree to the lowest degree. Now the other problem next to it, yeah, it's the same exact problem because, of course, I just want to prove my point that either way works. So step 1 again, we're going to keep change everything. That was from before. So you have our y squared plus 4y plus 2. You don't change what you start with. Now I'm going to add the opposite of 2y, which is negative 2y, squared. Plus, we change this. This subtracting 5 means it's a negative 5. We're going to make it a positive 5. And this 3 becomes a negative 3. So that's really the problem at hand. Once it's all addition, then we could go ahead and use those properties of adding things in any order we want, because we can. So we see that the y squareds go together. 1 plus negative 2, yep, it's negative 1. I don't need to write a negative 1. I can just write negative y squared. 4y and 5y still make the 9y. And 2 and negative 3 still make negative 1. So either method will work. It's up to you. I definitely for now need you to show me that rewritten step when you do subtraction. Please just trust me. I know that you get the big concept, but it's those little positive negative mistakes that will get you the 99 instead of the 100 on the test. All right, turn over your paper. Oh, I heard you go, oh, there's a back. Yeah, we have to do just a couple more subtraction problems, and I'll give you an application. Then we can make like a present and wrap it up. So right here, before you... And I didn't say this before, but this is subtraction in the middle. Before you change all this stuff, go ahead and add the opposite inside the parentheses. So when you go to take the opposite at the end, you don't mix it up. So I'm going to rewrite this first polynomial. I'm going to rewrite it without the parentheses this time. I'm a rebel without a cause, because I don't really need them if it's all addition anymore, and we're going to change that subtraction anywho. Okay, so this means I'm adding the opposite of everything in there. This was the negative 4p squared. But now, because I'm adding, it's a positive 4p squared. This was a negative p because it was subtracting p to start. Now it's a positive p. Good p. All right, this 3 was positive. Now it's going to be negative because, again, I'm adding the opposite of everything in there. Now go ahead and combine like terms. If you wanted to keep those parentheses in there, keep them wrapped up, and now line them up vertically, you are more than welcome to. I really do mean it. I'm just kidding. You don't have to do it my way. All right, so you have 1p squared, 4p squared. Those go together. They have the highest degree. I want to do those first. So 5p squared is what I end up with. Now we have p and another p. Yes, you have 2p. If you do, press pause and come back. I know, it never ends. I can't help myself. I really don't think I can. And last but not least, we have a 3 and a negative 3. And when you add those together, additive inverse, we get nothing. You don't need to write plus 0. That would just be silliness. No plus 0 necessary. This is standard form, highest degree to the lowest degree. All good. All right, next one. Again, keep change within your parentheses first. So I'm going to do that here, do that here. Over here, there's nothing. And now when I want to subtract this entire thing, that means I'm going to add the opposite of everything in there. So go ahead and let's rewrite this. Okay, so adding the opposite of x squared would be negative x squared. Adding the opposite of xy would be negative xy. And adding the opposite of y squared would be negative y squared. Now we're going to go through and combine some like terms. So I see the highest degree would be a 2 here. So let's see. We have, but we didn't talk about this. I have x and a y, and they're both to the second degree. In that case, when that happens, you just give me alphabetical. That's going to be the best way to go. All right, so alphabetical order, and then it'll be all good. So we have an x squared, we'll start with that, and and we have a negative x squared, so I guess it was a little moot point there. What happens when you add x squared and negative x squared? They are gone, they cancel out. So now I'm going to go to the next letter, negative y squared, and another negative y squared. Those don't cancel out. A negative plus a negative means you add normally and it's negative. So I have negative 2y squared. Those ones are done. The last thing that we're left with here is the xy's. I have a negative 2xy and a negative xy. That means negative 1xy. So again, I'm going to add up their coefficients. Negative 2 plus negative 1, that's negative 3. So negative 3xy. And again, just remember, the very best way to write this would be that. Either one is correct, though. They have the same value. All right, last example here is our application. I wouldn't recommend trying this one at home because you could really hurt someone, but it says, a penny is thrown straight downward from a height of 200 feet. Yeah, don't do that. If it hits somebody, it's really going to hurt. At the same time, a paintbrush falls from the height of 100 feet. My goodness, pennies and paintbrushes. I would be so frightened walking down the street. The polynomials, and there's two of them here. I'm going to get my highlighter going. There's one polynomial, there's another polynomial. Represent the heights in feet of the objects after t seconds. So here we go. Here's the penny. Up here, it's falling down from 200 feet. And then here's the paintbrush. It's falling down from 100 feet. You get the gist of it? Can you see it happening? I hope you don't literally ever see this happen, because it would hurt. Letter A says, write a polynomial that represents the distance between the objects after t seconds. And maybe you're thinking, well, how on earth am I supposed to figure that out? What am I supposed to do here? I'm guessing I would add or subtract, because that's what this has been about. But think about this for a minute, and you don't have to write these numbers down. I'm just going to. If this right here, let's say this was 10 and this was 5, the question I'm asking you is, what's the distance between these objects? How would you figure out the distance between them? You wouldn't take 10 plus 5, would you? No, you would take 10 minus 5 to get that distance. That's what we're doing here, except instead of me giving you a regular number, I give you a gigantic polynomial. So this problem, what I'm actually asking you to do is I'm asking you to take the first equation. I'm sorry, it's not an equation. It doesn't equal anything yet. I'm asking you to take the first polynomial and subtract the second polynomial from it. These parentheses are important because I'm not just subtracting the negative 16t squared. I am subtracting that entire amount. So you have to have those parentheses in there. Now I'm going to keep change within the parentheses first. And then I'm going to fix up this subtraction in between and add the opposite of everything in there. So I'm going to rewrite this as all addition so I can add them in any order that I want. And I want to add the opposite of negative 16 squared, which is a positive 16 squared. And the opposite of a positive 100 would be a negative 100. So from here, all we need to do is combine some like terms. So let's do that. The highest degree would be this t squared. And, oh, this is so nice. I love when this happens. When you have a negative 16t squared and a positive 16t squared, add the additive inverse, cancels them out. When you add opposites, you get nothing. That's right. Right, next, I only see one term that has a t, and that's the next highest degree. So I'm going to rewrite this as negative 40t. And the last terms in here, I have 200 and negative 100. When you add those together, we get 100. So this right here is a binomial or a polynomial, call it either one. It represents the distance between the objects after t seconds. And the last little part of this just says, and yeah, I'm going to finish it in 20 minutes. What's the distance between the objects after 2 seconds? Well, t represents time, right? So all I need you to do is plug 2 in for the time. That's it. Negative 40 times 2 is negative 80. And negative 80 plus 100 is 20. And we were measuring all of this, not in inches, not in centimeters, not in miles, in feet. Now you are done. I'll see you tomorrow.